Okay. Hello, everyone. So we're at time. Welcome to the INTAREA working group session. Sorry? Closer? Okay, perfect. Thank you. I'm Juan Carlos Zúñiga with Cisco.
Hello, everyone. Wasim Haddad.
So thanks, everyone, for being here. We have a pretty packed agenda, so we're going to get started right away. This is the new Not Well. So I guess you have seen it by now, but as a reminder, by participating to this group, you agree to follow the processes and policies, and we expect you to behave in a professional manner, courtesy to their colleagues at all time in a professional way. You have the reference there for the guidelines of conduct and the anti-harassment procedures. If you're aware of any contribution that is covered by patents, you have to disclose it as according to RFC 8179. For the detailed processes of information, RFC 2026 Internet Standards Processes and 2418 on working group guidelines. And as you know, the IETF routinely makes public written audio and video photographic records. So everything that you say or express here will be recorded. So make sure that you do log into Meetico, please, to record your attendance. And we will follow the queue as usual. So raise your hands on Meetico if you want to speak up. Otherwise, turn off your video and audio. These are the resources, materials for Meetico, and if you have any need for assistance, please go to the resources that you have here. So moving on to the agenda, we have some discussions and updates from our side, as usual, a little more than before. Then we will go to the multicast application port, Young Data Model, FANG, proposal updates to guidance packet reordering from GRET, ICMP from Jagan Babu, the DHCPv4 option for IPv4, David, defend the world from IoT remote threats and malware from John, IPv6 result, IPv4 gateway, Remco, ICMP error from Zafar. In time permitting, we'll have two presentations from K on ICMP errors and error messages. Any questions or bashing on the agenda? All right, so hearing none. So some updates from our side. We have two items that were adopted, the INTAREA ARP YANG model and the multicast application ports. So good news for those. On the last calls, as you may be aware, we've had some exchanges on the list about how to handle the last calls. And so the directive that we're getting from the ISG is that we need at least 5 reviews to progress drafts. So we have some drafts that are in the limbo now because they have been accepted. We've gone through last call, they've got support, but we don't have yet the 5 reviews to progress them. So this is key now. If you do support those drafts, we need to have some clear guidance and understanding from your side. And Eric, I don't know if you want to say something along those lines.
So everything has a responsibility for this. We do want indeed to get at working group last call, not only +1 by the authors, right, but real reviews. They are working group last call, right? So let's do a review. It takes 5-10 minutes of your time, and you can provide a very valuable feedback. Multiple pair of eyes are helping there. So thank you in advance.
Thank you very much. So we have questions on the queue. Bill?
Hi, Bill Fenner. Do you, for these last calls, do you consider them to still be open and ready for feedback? Because I was a little confused by the message you sent to the list, which said, we will issue another call And I didn't know if that meant we're calling now, or we plan to in the future reopen the last call. So you consider the open now and it's ready for feedback.
We had some confusion ourselves too, to be honest, because there's also the automated email that is sent by the tool whenever we change the status.
Okay.
So then it seems like we are announcing things and we're just trying to figure out in which state they are. And
sure.
The tool is already sending announcements.
Yeah. No.
So yes, I guess they are in last call, and we're waiting. The call remains open.
If I go shake some trees and rattle some reviews out now, that's okay.
Yes.
Okay.
Please. Tommy
Polly, Apple. So speaking for one of these that's in the last call state for the proxy config, so authors of that will be talking later today, because there was one good review we got from David that we couldn't read the content on initially, so we're going to process that. I guess that's one where I think we had a last call and then we did a second last call because we responded to initial comments. When we're looking at the 5 reviewers, is that cumulative across the different last calls? Do we need to re-ping the people who reviewed it on the first one to say re-up that? Or I just want to know.
Yeah. So first, the ISG and the ISG liaison to the tools team, that's me. We failed about this advertising to the chair, the change in the process and sending the email and so on, right? So 1 point. Yeah, it is cumulative, right?
Okay.
Except if the document has changed completely. If it was saying blue, it's saying blue, right? You need to change
it's mainly just responding to the comments.
No, that's cumulative.
Thank you. Bob?
Hi, Bob Hinton. Is 5 some magic number? Is 2 really good reviews sufficient? I mean, this seems a little bureaucratic.
No, the 5, I made it this number, right? To be clear, it's 5 authors and something like a magic numbers, because I got 5 fingers on my hand. We would be another planet, would be 6 or 7 or 3, right? But again, there were some drafts I've seen in some working groups with 3 authors, and in group last call we get only 3. Yes, okay, by the 3 authors. Right. We've seen this. I don't want to get this.
Since we're talking about process, my view on when you do working group last calls or whatever, the only thing you want to hear from the authors is that they don't support it. If they're having to say they support it, sort of their name is on the document, that's enough. So that would mean there was no response to the last call. So those don't count at all.
Okay. Thanks, Bob. All right. So I guess that clarifies the issues about the last calls. Then we had some more that were finished, and then we had one that is waiting for an updated draft, and it's expiring soon. That's the INTAREA tunnels. There was some pickup after some time on that draft, and there were a lot of feedback to the authors, but we are still waiting for the updated draft, and it's expiring soon, so that needs to be addressed. And finally, we have one that is in discussion, right, Eric, at the IESG. So I think it left this group, the last one, the ICMP extended header, but that's up to the IESG exactly what happens with this last one that apparently will be withdrawn.
So indeed, on this one, there were discussions about basically how we can deploy this without breaking the other stuff. That's what I did in my AD review. But the feedback I get at the working group, from the working group at that point of time, say, let's proceed. So I proceed by, clearly IEC got the same command as me. So in the state, it will not be adopted. My understanding from talking to the authors, and most of the discussion had been on the mailing list, is that the main, I think, one of the important authors, Ron Bonica, I'm not sure this in the room, consider that it needs to be, there is a big issue, and this document should really not be working on. Some of his co-authors do not agree. But currently, I would suggest that this document is unadopted, and the authors that wants to remain maybe ask for another call for adoption, because it's clearly in the limbo right now. I mean, it happens sometimes, right?
Okay, thank you. All right, so I think that's good for us for the slides. So now let's move on to Nate.
Good morning.
Let me go on. 1 second here. Can you share from your side, or you want me to?
If you could share it, I can control the slides. That'd be great.
Okay.
Okay. Thanks and good morning, everybody. This is about the multicast application port. So we'll start with developments since the last meeting. Last meeting, it was pointed out that port 49149 was going to be in the dynamic range of many popular OSs. So we changed this to 8738, which in hex would be 2222. We chose that because that would be easy to see in your traffic capture tool. And we have an internal note at IANA updated that basically indicate that we're requesting this so they don't assign it to somebody else in the meantime. We capitalized the requirements language so that it would follow RFC 2119. We added notes about the benefit of using a port assignment to the abstract and the introduction. Added a note on using multiple sockets when applications mix the unicast and multicast. And then we also added guidance on how updated hosts should respond to invalid operations. So for example, if you're trying to bind to the wildcard, bind that port using the wildcard address, that would return an error. Okay. So running through this again, we'll probably go fairly quickly to leave room for questions because there was some comments on the mailing list that we could go through. So we want to kind of contrast here demultiplexing for unicast traffic. In the IP transport protocols, the port numbers are used to do that, where you have one host running multiple applications. Traditionally, each application protocol has been assigned a port, but because port assignments are relatively scarce, that's kind of gone out of fashion. So what we've been doing is switching over to dynamic ports and advertising using a DNSSD. With multicast traffic, you actually don't need to use the port because the multicast address serves as an identifier for the application itself. But if you are using the port, you have to basically assign a port to everybody because it's hard to coordinate without some sort of global static port assignment. So what we want to try to do here is recognize that multicast applications don't actually need those ports for demultiplexing because you've got the IP address already. And furthermore, if you're going through all the effort of getting that traffic to the destination, you should use it. That port field is redundant. Want to note here on how multicast addresses are assigned. You can have fixed addresses where IANA assigns IPv4 and IPv6 multicast addresses. You've got the registries listed there. And then we have a couple of documents that discuss how dynamic multicast address assignment would work. RFC 2730 is a central server-based assignment, and then there's two kind of more peer-to-peer based assignment protocols working their way through the PIM working group right now. I think that first one, the zeroconf one, that's in last call, and then PIM gap will be up for that next. So our proposed solution is to assign a UDP port specifically for use with multicast applications. Again, that's hex 2222. And then we kind of list out what conformant applications and conformant hosts would do with this. Conformant applications would set the reuse adder and or the reuse port socket options so that they can share that with other that port with other applications. if you are running on a non-conformant host, you can actually start using this right away, which is an advantage of what we're doing here by assigning a port specifically for multicast versus doing something else where we take out UDP entirely. So host stacks don't need to be updated, though there are some benefits to doing so, which we'll talk about next. Our recommendation is that conformant hosts would require the reuse adder or reuse port, and this would return an error if you're attempting to use this port without setting that. And that gives the benefit that if you are writing the software on a conformant host, then it would also run in a non-conformant host. We also want to prevent the use of that port with a wildcard address. That way it would limit its use to multicast addresses. Prevent applications from transmitting non-multicast packets to the destination. The reason for that is that there's no good indication as to where that, which application that should go to. Unicast is typically round robined by the receiving host, whereas multicast is given to every application that's bound to that port. And then we would also discard all non-multicast packets arriving there. So that's kind of both ends of that. One is that you'd be permitted or prevented from sending, and the other one is that you would be prevented from receiving. We have a couple of demos of this working. There's a pretty basic SOCAT demo at the IETF 118 PIM meeting. You can go look that up if you want. We also have example code out on GitHub there. There's two versions of that, the POSIX version and the Windows version. And that's because they have different requirements for using the socket APIs to bind to multicast. This came up last meeting, but the big thing to note there is that the POSIX, you bind to the multicast address, whereas on Windows, you bind to the interface address, and then you add the membership later to start receiving the traffic. Okay, we can open up to questions now.
Dave?
Hey, Nate. Thanks for responding to my email. So I think we're making some progress, but I don't know if you saw my response, which was after the beginning of the meeting, but before you got up, which was basically right on your last two things. And so I think there's really only two approaches where I'm thinking we probably should do the second, but the first approach is to actually allow it to be used as allow a unicast packets to be sent with the source port here, which the document says don't do that. So that would be the first option in order to allow things to get through firewalls, right? So for everybody else, the scenario is you're using it for a discovery protocol. So some client sends a message to the multicast address and this port, and then it expects to get a unicast reply, so it then has discovered the server, right? And the unicast reply, if it has to come from a different source port, it can get dropped by the host firewall on the client because it's an unsolicited inbound packet as far as I can tell, right? So that's what we're discussing here between Nate and me. And so the second approach is to say, have like an applicability statement, the .graph that says, this port is not applicable for use with discovery protocols, and you must use some port other than this one for all multicast packets or all multicast traffic that's used for discovery. I'm guessing that's going to be the simpler approach and just limit the applicability to this one to things that are just exclusively multicast that don't have this problem, or are in constrained environments that are known to not have host firewalls, but saying that is pretty dangerous. So that's why those are the two approaches that I see. I'm interested in your views on how you'd like to address it. Thanks.
Yeah, thanks for your comments. I think I'm going to have to look at the mailing list and maybe do some research on how those host firewalls work. You mentioned an RFC 7288. Is that a pretty good overview of the problem you're describing?
It's probably a little bit too high level to go through this particular example, but if you're going to mention host firewalls that block unsolicited inbound traffic, then it's probably the best RFC that can be referenced right now. Obviously, there's many different host firewalls that work differently, but this is a common technique of host firewalls that want to block unsolicited inbound traffic. And so it varies again by firewall. So you might have a firewall that doesn't do this, and the other guy does. And if you're running the server, you don't know what the client has if you're running a client server-based mechanism, right? So for general deployment on the internet, you cannot assume that a unicast reply from a different source port will actually come back. So.
Okay. And when you're saying host firewalls, you're talking about every host on the network, even on an internal network, would have that versus something kind of at the edge.
Any host that has its own firewall as part of itself, right? So like a Windows firewall or, McAfee or, et cetera, that are firewalls you install on the host itself. So.
Yeah. Okay. Yeah, I'll take a look, and we'll keep the conversation going on the mailing list. So, okay. Looks like we're about out of time. Thanks, everybody. Enjoy the rest of your day.
Thank you very much. All right. So next is Thing, I think. Do you want to share from your side, or do you want me to share?
Oh, you can share it.
You should be able to control now.
Okay, thanks. Hello, everyone. This is Fan Zhang from China Telecom, and I'm presenting the a young data model for ARP on behalf of the other authors. This draft defines an IETF ARP young model, which covers the extra bits of ARP implementation that many vendors support, but not covered by the existing IETF young models, including the features like proxy ARP, gratuitous ARPs, and the related statistics. And here is the young tray of IETF ARP we defined. And the basic ARP functions, such as the static neighboring entry, are already defined in IETF IP model. And as for IPv6, the corresponding basic functions are also defined in IETF IP. And we've submitted another draft to extend the IPv6 ND young functionalities. Here is a quick recap about the draft history and why we are here. You may notice this one was originally an RTGWG workgroup document, and it has been stalled for a while due to the lack of equivalent IPv6 young model. And last year, it was resumed following the new submission of IPv6 ND young model draft. But during the RTGWG session in Madrid, there was a discussion suggesting that 6man might be a more suitable place for the V6 draft than RTGWG, and it concluded with moving the V6 draft to 6man. And along with that, this ARP draft, as the corresponding V4 part, was also moved from RTGWG to INTAREA and got readopted later. And we think this one is a very basic young model, and it has been quite stable as the last few revisions only made some editorial changes. So we think it's time to, maybe it should be moved forward now, and we'd like to request the workgroup last call. And that's it. Any comments?
Thank you. Any comments for Fen? Okay, so we see no. I would like you to request feedback on the mailing list, I guess. If you want to proceed, we would need to see some interest and support from the group. But
Okay.
yes, please do trigger a discussion on the mailing list.
Yeah, okay.
We have one comment from Eric.
Out of curiosity, may I ask for the people in the room to raise your hand if you have read the draft?
Okay.
For notes too.
We see 3, 4 hands. So yes, please do read the draft if you have some interest, and then if you want to discuss this, that would be needed to progress the draft.
Okay, and thanks.
Thank you. So next is Greg, I think.
All right, hello. Slides are coming up. So this is a second time presenting this draft in INTAREA. The first time was 2 IETFs ago. And the title of the draft is Proposal for Updates to Guidance on Packet Reordering. Since the last time I presented this in INTAREA, I've been joined by a fourth author, Chris Box from BT joined, and has contributed to the draft, to the evolution of the draft. So I'll do a quick recap of the presentation I did in IETF 122. Link to the slides are there, and I'll just cover the first 3 points just to recap the background of this. Certain link technologies, layer 2 technologies, result in the delivery of packets out of order across the link. There are 2 main reasons for this. One is link aggregation. If you've got multiple links that have different characteristics, delay or capacity, the order the packets arrive at the receiving end of the link differs from the transmitting side. And the second main cause is layer 2 retransmissions, where commonly in wireless links, this can happen where individual packets get retransmitted at the link layer. Many actually of the layer 2 standards have requirements around the receiving end of the link resequencing the packets to restore the frame sequence. And it's important to note the word frame there and not packet or connection. This really is done in, generally on the aggregate of packets in the layer 2. And so the question is that what IP protocols want? There is some existing guidance in RFC 3819 that talks, the scope of 3819 is to talk about expectations on layer 2 networking technologies. And it points out that the architecture of the internet doesn't guarantee in order delivery, and mentions that transport protocols like TCP, I think that actually probably should have been more general, protocols that run on IP need to take this into account and handle out of order arrivals. And then it has some nice guidance that says layer 2 links should try to avoid packet reordering whenever possible, but not if doing so compromises efficiency, impairs reliability, or increases average packet delay. But then it has 2 caveats to that guidance, which are pretty scary. One of them is basically TCP is going to perform terribly if you deliver packets out of order. The second one is you're going to break every header compression scheme currently standardized on the internet. Perhaps for that reason, those caveats, we got this state where layer 2 networks have a lot of requirements around frame ordering and frame resequencing. So the goal of this draft is to update that information so that layer 2 SDOs can take more current information into account in the evolution of their technologies and make more informed decisions for the future evolution. The other slides that I presented last time go into this a little bit more detail, and the gist of it is latency is increasingly important, and these requirements that guarantee in-order delivery at the link layer, they increase latency, not just for the connections that are sensitive, that might be sensitive to in-order or out-of-order arrivals, but for all of the traffic on that link. So you can imagine a link that's carrying an aggregate of multiple connections. One packet is lost and needs to be retransmitted. all of the other packets that that arrived into the link at a higher sequence number are getting delayed for this one packet that may have nothing to do with the packets that are getting delayed. We have some anecdotal data at this point. The one goal of this work is to get better data around this, but anecdotally we've seen cases in mobile networks where this resequencing function adds hundreds of milliseconds of additional delay to aggregates of traffic. There was a study that, in 802.11 around what impact this resequencing function causes in Wi-Fi, and in certain cases it increases the average delay for connections by 50 milliseconds. So these are not small numbers, and again, it's in a lot of cases probably impacting traffic that you're resequencing for no reason, that the receiver of the sessions would have no knowledge that the out of order arrivals happened at the link in the first place. So adds latency, adds cost and complexity in layer 2, and I can speak more specifically on the DOCSIS protocol, where we do have a lot of requirements around guaranteeing in-order delivery. There are something like 70 pages of spec text that talk about the resequencing function. It's very simple conceptually, but when you get to the details, it can get complicated. And provides no value in many cases, not just because of the aggregation situation, but also most modern protocols are much less sensitive to packet reordering than they were 15 years ago when 3819 was written. Let's fix this. So at least update or remove the text about TCP and header compression. After the publication of 3819, one of the goals of the ROHC work was to eliminate the dependence on packet ordering, and that work was completed. TCP now, most of the modern stacks support RAC, which is does loss detection via a RAC window. It's not based on DUPAX. So can we come up with something? Well, let's at least eliminate that outdated text. But can we come up with something better, some better guidance, both for layer 4 protocol developers in terms of how much reordering they might need to tolerate, and potentially also better guidance for layer 2 protocol developers on how much reordering they can create. And so seeking input from folks who are experts in layer 4 protocols. What are the gotchas here? IPsec is one that's been brought up that depending on the implementation, there are limits, potentially small limits on the replay attack windows that could get tripped up if packets are delivered out of order. But we need more information from the community. A side point is related to the, can we come up with something better? There's this question of how do you quantify reordering? There are a lot of dimensions to that, and there's actually an RFC which provides a handful of different metrics that could be used to quantify reordering, which may come into play in this discussion. So the status of the draft. We uploaded the draft 02, which now has a new section 5, which actually is proposing specific text to update RFC 3819. It's a first attempt at that, so still needs some work. The draft is being worked on in GitHub. There are some open issues that are listed here. In particular, one of them is suppose there are implementations or protocols that that have to retain some sense of a sensitivity to out-of-order delivery. Are we expecting layer 2 networks to be aware of that and be able to resequence protocols, specific protocols? In case, a question for the INTAREA, do you agree this is a problem worth solving? And would you help solve it? And actually, a third question is INTAREA the right place? I did a presentation on this yesterday in TSV working group, and there was some discussion around transport people are pretty interested in helping solve this problem. And so is it, yeah, it's right here. So
Thanks, Greg. Richard?
Hello, Richard Patterson, Sky UK. I am by no means a layer 4 expert, as you requested, and I haven't read the draft yet, so I'm afraid I will do that. The concept of increasing out-of-order packets does scare me in general. I would ask to consider and have a look at, or at least mention, things like stateful translators. Regular carrier grade NAT or NAT64 translators will have issues, and another call out for that specifically. Or maybe if you do relax the out-of-ordering in general, highlight fragmented IP packets, which will require more effort on those other stateful devices. So it may be that the layer 2 devices do have to put in more effort to ensure in-order delivery of fragments and maybe the others are less priority.
Okay, thank you.
Thanks. Well, I consider myself in the queue, Juan Carlos Zúñiga, Cisco. Is your intention to stop at guidance, or are you also planning to do some quantitative analysis and then go a little beyond on, we know we discussed this, it touches on L4S and other topics that we've been discussing, the different fora. So how extensive are you planning to?
Wes, I think to help the discussion and help us make decisions on what goes into an eventual RFC, I think more data is very helpful. I think data both on what would happen if a layer 2 technologies that are widely deployed today, if they turned off this feature, what would the impact be? Similarly, data on existing protocols, existing implementations of protocols, how sensitive are they? So absolutely would welcome experimental data or data collected on live networks. Yeah.
Thank you, Eric.
So Eric Ving, Cisco, but also responsibility for INTAREA. So it was nice that you talked to TSV yesterday. Do they want to adopt it, or?
We didn't get that far in the discussion. So currently the draft is an INTAREA draft. I don't particularly have an opinion one way or the other, but yeah.
So and basically, typically, this draft is in between two areas. So typically, in this case, what we do, we adopt it if the working group allows and wants in one working group, and we do all the extend the call for adoption to the other, so they are aware. We do the working group last call in the two. So it's not the first time, it's not the last time, right? Don't take it as a blocking factor. Could be useful, by the way.
Okay. All right. Thanks.
Oh, and the source of multiple master thesis.
Yeah. Okay.
Bob.
Hi, I'm Bob Hinden. So, of course, this is not a new problem, or you're not the only one to notice it. It seems to me this is more of a transport issue. IP doesn't really care about out-of-order packets. They're not, it's a transport. The sort of the next thing up, in the protocol stack cares a lot about it.
Right.
But I'm guessing the intention of this is not a message to the IETF. It's to the IEEE, and from looking at the document briefly, we're not sort of the customer for this document. It's really other groups who do layer 2 technology and trying to get them to think about this.
Yes and no. Yeah, originally that was my thinking. I guess going back to this slide, potentially adding better guidance for layer 4 protocols as well. Going beyond just saying transport protocols like TCP, you need to take this into account, but having better guidance in terms of how much reordering links might create. Yeah.
Right, because it's, I think most people who work on transport protocols have some probably fairly good understanding of this now, because you don't need to get it to zero at reordering, but you certainly don't want it to happen a lot. So I think there's probably the center of this may be more in transport areas, like as it's good that you went there and presented it, but I think it doesn't feel to me it's the IP layer can do too much about this, or what, or what are the actions from this document, and who's going to take those actions?
Yeah. I guess IPsec is another one that's been again mentioned. And
So quickly, Frank, again, to reply to Bob, the internet area in general not only do the IP layer, but also the sub-IP, the link like 6LoW and so on. So could be fit here as well.
Rüdiger Volk. I wonder, stepping up on such basic stuff with experience from 29 years ago, when as an operator I enabled reordering and hurt my customers badly. The thing that I ran into, and a very superficial scan of a document did not show mentioning of a problem. If you have fragmentation and you have the fragments reordered, the receiving party may get into trouble. And real life experience 29 years ago.
Okay.
Ron, you want to make it quick?
Yes. Ron Bonica, HPE. I'd like to add on to something that Bob Hinden just said. He said that the center of gravity of this problem is at the transport layer, namely TCP. I think that's where a lot of the gravity is. But there are lots and lots of applications that run over IDP that handle reordering in their own strange and wonderful ways. We don't even know the names of these applications. So yes, TCP is a point of a lot of gravity, and there's a lot of gravity in other places that live above UDP, and it's hard to find those.
Yeah, fair enough. Okay, all right.
Thank you. Lots of good feedback. So next is Yagan Babu. Are you in the room?
So this is Madan. I will present the draft.
Okay, I'll pass you control to the slides now.
Okay, so hello everyone, good morning, good evening, and thank you for joining us. My name is Madan Sankaranarayanan, and I'm here today with my co-authors Jagan Babu Rajamanikam and Darren Dukes. This is my first IETF presentation, so I am especially excited to be here and share the work with you. We are presenting our draft titled ICMP extension to include underlay information. So our agenda today is straightforward. We'll start with the problem statement. Next, we will present a motivation example to illustrate the issue. Then we'll introduce our solution, the underlay information object. We will do a deep dive on UIO object format, and then we finally will outline the next steps and open the floor for Q&A. Okay, so let's start. Network operators today face a significant challenge when managing the complex overlay networks. They require clear visibility into the underlying physical or logical network hops during traceroute operations initiated from the overlay endpoints. The core issue arises when different address families are involved. For instance, if you have IPv4 domains connected through an IPv6 core, okay, then the current traceroute process simply cannot map the IPv6 hops within that core back to the IPv4 nodes. this creates a critical blind spot, especially problematic when the access and core networks are managed by the same administrator. So existing ICMP extensions, which are defined in RFCs at 4443 or 4884 or 5837, do not inherently solve this cross-layer visibility problem. They lack the ability to bridge address family gaps or reoriginate errors with encapsulated cross-layer information effectively. So let's consider a practical scenario. Let's consider practical scenario as shown in the figure. Whereas the IPv4 access networks are connected with the IPv6 core network. Okay. So whereas imagine a traceroute operation is initiated from IPv4 router R1 within an overlay network. So let's take a failure scenario. Okay, so if a packet drops deep inside the underlay IPv6 core, okay, so then currently the current state, whereas if the overlay operator, if he performs any trace route to triage the problem, then the current trace route results will not display any specific information about the underlay IPv6 hops. Okay, whereas the operator receives only a generic ICMP error. So the critical gap here is that the current ICMP messages, whether IPv4 or IPv6, do not have the ability to carry the information about other address families. So the error messages lack the identity, the address, or the name of the specific underlay node where the problem actually occurred, making the troubleshooting extremely difficult, right? So to address this, we propose a new mechanism, whereas underlay information object UIO. Okay, the function of UIO is to act as simple standardized envelope. So what it'll do is it carries existing standardized ICMP extension objects such as the interface object from RFC 5837, which contains the actual underlay failure information. So this is how it works. So when an underlay node, if it experiences a failure, then sends its specific ICMP error to the source. So crucially, the underlay node originates a new ICMP error message directed to the overlay source. So here, I think I made as endpoint. Okay, endpoint is a mistake. So it's actually the message to the overlay source. So now the new message contains the UIO encapsulating the diagnostic information from the initial error. So the ICMP extension objects encoded within the UIO ICMP extension objects can belong to any address family, irrespective of the address family of the source node that decapsulate the UIO ICMP extension objects. This is actually a post which is stated in RFC 5837 section 4.2. And if the underlay node, if it is not capable of sending with UIO, then the header node which supports both address families can send the information with UIO. So existing rules in RFC 443 section 2.4 currently prohibit originating an ICMP error from another ICMP error. So the header node has to re-originate the ICMP error message, and that is the specific exception that we define and require for the RFC 4443 update. Hence, our UIO proposal requires a specific exception to the rule to enable the vital diagnostic visibility. So let me deep dive into our UIO object. So our UIO object, it adheres to the standard ICMP extension object format comprising the length, class number, and C type fields. So the length, which is 2 octets, this indicates the total length of the object, so including its header and the payload. The 8 bits class number, which is used, and it will be a new ICMP extension object class number, and which are requesting INA to assign a specifically identifying this as a UIO object. And the C type, which is one octet, and this is the object subtype. And we define C type as 0 as of now. And this could be later we can go ahead and add additional C type values in future. Okay. Then we have the object payload, which is a variable length. And this payload contains one or more ICMP extension objects that provide information about the underlay node. And it must contain at least one ICMP extension object, typically from RFC 5837 for node identification. And key aspect of UIO is its flexibility and address family agnostic. It allows for carrying IPv6 failure information to an IPv4 source or vice versa. So effectively bridging the address family gap and currently hinders cross-layer functionality.
Just a 2-minute reminder, and you have some people in the queue.
Sure. So in the summary, UIO effectively closes the cross-layer visibility gap by providing a standardized, secure envelope for underlay feature data, and it empowers network operators within the crucial diagnostic information needed to troubleshoot issues in complex overlay environments. So, yeah, thank you for your attention. And the draft is also reviewed by Ron Banico, and he also updated some comments. So we'll update his comments and update our draft. We are ready for any Q&A or comments or feedback. Thank you.
So, Bill?
Hi, Bill Fenner, Arista Networks. Are you familiar with the draft INTAREA ICMP extended node ID document? I ask because it sounds exactly like your proposal. It allows you to include an address or a node name or both from in the exact format as 5837 does. And there's a companion document that allows a v4, v6 translator to include the address of a v6 node in an underlay to the ICMP message that it translates back to the ICMP, to the IPv4 source. So between these two documents, from a high level, it sounds like everything that you've proposed in your problem statement is covered.
Okay, sure. So we'll have a look on this document and we'll update that. Yeah, thank you. Thanks for your feedback.
Sure.
Thank you.
Yeah, excellent. Thank
Hi
you.
there, Tom BT. Are you able to go back a slide?
Sure.
I think it's just useful. The crucial update there was actually, nope, too far. That one. The crucial update there, I think, was actually quite useful. That was one of the things that was concerning me. I think the other thing that's slightly concerning here is that I don't see any limitation of which ICMP options and types that you might want to actually send in this direction or at all. It feels like there's a lot of things you can do with ICMP that could potentially be either very confusing to an overlay network or slightly abusive potentially. I like that this I like that this update does say that they must not originate an ICMP error message on the result of receiving another one. So that's good, right? That cuts off a good chunk of the potential abuse. But I do feel that we might want to limit which types of ICMP options you would want to ever send in this direction. You're effectively crossing the streams here. So I think it would be very, very sensible to be very careful about what you're sending. Potentially Bill's point was more important than mine. So thank you.
Thank you.
All right. Thank you very much.
Thank you. Thank you.
So next on the agenda is David, I think.
Hello. Do you have a? Yeah. Hello, everyone. This is IPv4 routes with IPv6 hops, next hops in DHCP. We've been working on this for a little bit. If you don't have the context on this, you really need to go read a few other documents. Doing IPv4 routes with IPv6 next hops has been around for quite some time. This is not the place to go through it again. There's the pointers here. The middle, the INTAREA v4 via v6 one is, I think, through working group last call now. And it's just a v4 route with a v6 next hop. That's it. That's what this is. We do know that this works perfectly fine between routers. It's an active use there. It's used especially in data centers with BGP zero configuration kind of setups, where you have a linked local address v6, works perfect. Eurix people are looking at using this at exchange points. That would allow them to get rid of having an IPv4 network for the exchange point at all. But this is just to say the feature itself is widely understood, widely known, and widely available. What we don't have is a way to get this ready to the end hosts. Right now, what you can do with an end host is you can use a classical subnet. Worst case, it's a 30, in which case you use 4 addresses to get 1 address to the end host. I hope no one is doing that anymore. You can do a 31. You still lose 1 address per host in that case. And you can do a 32 on the host and have another 32 on the router, which hasn't quite been described anywhere in RC as far as I know, but is reasonably available. There's a special case of this that kind of will be presented later by Remco using a well-known address for this. However, what we would like to do here is have the host use a IPv4/32 and give it an IPv6 gateway address directly. So this is really a problem of how do you deploy this, how do you get this to the host. If you can just execute commands on the host, you don't have a problem. You can just call the appropriate setup commands, install the route, you're done. Then you don't need this. You do need this if, for example, you have an admin boundary between the end host and your router and you're using DHCP. You need some standardized way to deploy this. That way doesn't currently exist. And while we're at it, we also need to make sure that the other direction works where the router needs to reach the host, because this is in DHCP giving the host the reachability to the router, but I'll get to that. So we want to use individual addresses. That's the goal here. I kind of went through this. We want the IPv4 routes on the end host. There's a side goal to reduce reliance on ARP. That's not really the main thing here. It's a nice side effect to have. But we'll take it. We are considering for this the DHCP client on the host to be something that can be touched and changed. If you can't do that, you're stuck with having a shared IPv4 address on the router somehow. That needs to be either something that you allocate or the address that Remco's draft is later going to present. But to be talking about anything here, it only makes sense if we can touch the DHCP client on the end host. So what are we going to do? We suggest adding a new option in DHCP v4. This is not DHCP v6. To have an IPv4 destination, a route for that, with an IPv6 next up. This is very similar to the option 121, which is the CIDR static routes, which is reasonably deployed, kind of hit and miss. I tried putting a short diagram there at the bottom. You just get your DHCP reply from the server, probably through a relay, and then instead of having the router option in there, you have this option. In most cases, the destination subnet will be 0/0, which is a default route, and then you have an IPv6 address as a next stop there. I'm hoping that this will in most cases be a linked local address. That's the most sensible way to deploy this. It's not technically required to be a linked local address. You can put other things there. Maybe not the multicast address. That's not going to work. This is only the first half. It does have a few issues by itself. First of all, the way DHCP works is, regardless if you have a server or a relay on the link, you do kind of need an IPv4 address in that to identify the relay and or the server. And we don't quite have the other direction working if we just do this. In theory, we can snoop on the DHCP traffic, try to keep that somewhere in the router. We could also just come up with some fake address, send ARP, have the host respond to ARP. This is all possible. I'm going to call it fragile, because it's probably going to be fragile to try and extract the data from someplace it wasn't quite specified to do this. Right, and we can't install a v4 over v6 next hop route on the router. If we do this, we need to kind of mess with things there and use the MAC address, and may need a fake IPv4 address or something like that. So maybe let's try to avoid this. So the second half of this is we use DHCP v4 in DHCP v6. This is RC7341. This was originally designed for, I think, softwire deployment, like lightweight 4/6 and CPEs or something. It works perfectly fine. We did actually try this. We had this working. Side effect of this is the router, or rather the DHCP relay on the router, now has a linked local address for the end host that it can use for the route in the other direction. And we can use a normal v4 route with a v6 next hop on the router as well. What this looks like at the end is you still have DHCP v4. It's just wrapped in DHCP v6 in a special message type. For the details, please look at 7341. And yeah, there are some caveats here. I already mentioned the relay on the router looking at things. The router doesn't need to know which IPv4 addresses are assigned to hosts on some link. So this assumes that the router is going to snoop on packets that are passing through a DHCP relay that is running on the router. In the best case, this is going to be a DHCP v6 relay, because that's much cleaner than a v4 relay, but either will theoretically work. This will break EVPN if you rely on ARP snooping to get your proxy ARP entries. The best way to get around that is to use gratuitous ARP, question for itself. We would also suggest putting some compatibility value in DHCP, so you get something to work on unmodified clients. I think I'll leave this for Remco's later presentation and put these two presentations together and think about them combined. That's it for me. Anyone have questions? If not, we have questions.
We have Lorenzo.
Yeah, Lorenzo Coliti. So there was a lot of debate around putting routing into DHCP6. It was lively debate, and we sort of like rejected it twice here, the IETF. And the reason is that, you know, RAs provide fate sharing, multiple sources of information.
So that is
right. So
that is why the v4 on this slide is underlined in red. This is not a v6 option. This is not a DHCP v6 option at all.
no, but like DHCP4 has similar limitations to DHCP6. You can't change anything. And so the next, like the thing that I'm talking about here is like the next hop there is once you've given this DHCP4 option, what basically you shouldn't communicate a next hop in a protocol that has no update strategy.
Yes, but the analog to an RA in IPv6 would be IRTP for IPv4, and we know that nobody uses that.
No, my point is that you just cannot pass the v6 next hop here because you don't have an update strategy. You basically have to refer to future RAs somehow. I don't know, but that is a problem, right? Because if you do this and then the RA basically goes away and you plug in a different router, v6 will continue to work and v4 will break.
Yes. So it doesn't make things worse, I'm going to say. You already have this problem with v4 if you change the router's v4 address.
No, because ARP will make it work for you.
How?
Like if you change the, you can do VRP, right? But like my point is you need something. Okay, so you're saying you run VRP v6 for this. Okay.
For sake of time, I will bypass everything and no head. The business assumption here is pretty much like Lorenzo said. You assume that the DHCP server/relay is a router.
You can put a different address in there. Like you can give the link local address of somebody else. You don't need to have it on the...
Fair enough.
Yeah.
And the other point, I wondered, it's a nice exercise. What's the added value of doing this?
The point is to be able to use individual V4 addresses in your network without any IPv4 on your router. The goal is to get rid of any V4 address in your core network entirely. Your routers will only have V6 addresses.
I'm not convinced on the... Anyway, thank you.
Okay. Thank you.
Timothy? One last question.
Sorry, more of a comment. I suspect the DHCP group is going to have, I'm wearing my DHCP working group chair hat. We're going to have some comments on this. I assume the V4 server guys are going to hate this. I'm going to tell you right now, they're not going to like sending this info directly over there. And then the snooping issue, yeah, I would suggest running this draft by the working group. I think it belongs here. I don't think it's a DHCP, but I think you're going to want to get their input before you do anything.
I've spoken with some people individually, but yes, we should go take this to DHC. Thank you.
Thank you. Now is John.
Good morning. Good afternoon. Can you hear me?
Yes, we can. And you have the control.
Awesome. Thank you. So I wanted to apologize, first of all, for the I guess the sparseness of this. It was kind of a rush job to get this in time for the cutoff, so apologies for that. There also is an IPR that I am working to file. So that is, I guess, a full disclosure for that. This is to basically solve a problem, or at least make a problem more manageable for IoT devices that basically you put on the network without knowing what their full capabilities are, or what they're trying to do, what they're providing, and what they're consuming. So we wanted to put together a standard around how those resources are advertised to the router, and also to make it the home router. And we're kind of thinking IoT, not IIoT, but IoT for home networking. Why do we want to do this? It's, Mirai was a big issue. I think we're all still remember that. And it looks like IoTs are expanding, and we're looking at roughly 17 billion devices, or twice that, by 2030. So the basic protocol, it uses JSON to advertise categories from the IoT to the router. And the router will advertise either a revised version of that, or accept it and just echo the JSON object, or a special status object of, everything's accepted. One thing that did not apparently get explained due to the quickness that we put this together, is a registry that we are hoping to have hosted by IANA that will have defaults for all of these categories. So for example, video streaming would have the default ports, default default ports for consumption, and for providing, if it's going to consume, for example, video streaming, it will advertise that in its DHCP, in this JSON payload. If we can get this registry where the defaults are kind of set in stone through the registry, it would only need to supplement that information in the packets so that we could keep the payload limited in size, because this could be something, if your IoT device does 1,000 things, advertising all of those could definitely eat up a lot of
Sorry.
bandwidth.
Sorry to
packet
interrupt.
size. Yes.
The sound is very loud. They are asking if you can move a little far away.
Yeah, let me see. How's that?
Better. Thank you.
Okay, sorry. So in the basic overall operation is during the DSCP negotiation, the IoT device would advertise its feature set. That would be what I use, what I provide, sent to the home router, and the router would either mandate that things are changed, whereas the IoT device itself doesn't really care what's going to be enforced. It's just going to be enforced at the router, but it's provided back to that IoT device in any case. And there are some examples in the draft, but I definitely would find any kind of feedback from that, since this is a zero draft, helpful. So thank you.
Okay, thanks a lot. So we have some time for questions. There are some comments in the chat, and Stuart is in the queue.
Hello, I'm Stuart Chair from Apple. I'm probably going to ask the question that I expect a lot of other people are thinking. If the IoT device is infected with malware like the Mirai botnet, what makes us assume that that malware is going to honestly say, I shouldn't be doing the thing I'm about to do? Aren't we trusting the malware to tell us that it's malware? And that seems like a loophole in this.
That's a good point. The default behavior of the router is to block everything that's not specifically asked for. That can be confined. We're envisioning an administrative portal in the router that would allow you to map categories as far as what categories you default accept, what categories you have to be interactive with. So if it asks for something that doesn't seem like it should be used, for example, a camera is probing your network, a camera is trying to initiate a lot of traffic, that's going to be default blocked. If it decides afterward to renegotiate its characteristics, that would have to be renegotiated through the administrative portal, and the admin can decide to allow that and not allow that. So everything, and apologies for not making that more clear, the default behavior is block everything that's not asked for.
I think what's implicit in the way you describe it is you're assuming that you know this is a camera, but all you know is what it tells you, and it's going to lie to tell you whatever will get it the permission it needs. So I don't want to just stand here and criticize. I have a suggestion.
Yes.
I think a good place for you to take this work is CSA, the Connectivity Standards Alliance, which is the new name for the old Zigbee organization, which is where the work is being done on the Matter home automation protocol. And without going into lots of detail now, because we're kind of out of time, they have lots of cryptographic protections and device certificates for device attestation. So you can actually tell what role this thing is because there are certificates on the device that say so. And there's a lot of infrastructure that goes into place to make that work, and certificate hierarchies. So it's a lot more than just IANA registry. But because they have those cryptographic chains of trust, that actually puts you in a position to have the gateway know that when this thing says it's a camera, it really is a camera, and therefore I can apply a policy that's appropriate to that kind of device. So that, if I was doing this, that I think is the right venue to do that, because they have the support in place to do that kind of thing.
Thank you.
Thank you. Ted?
Ted Lemon. Yeah, so there's just like 15 people in the chat said, have you looked at MUD, Management Usage Descriptions, I think?
Yeah, I did. Actually, I was working with the chair of the DHC working group, and that was the first thing they pointed out as well. There is definitely some overlap there. I feel like it's a little more complicated to implement because it needs to switch to a different protocol. One of the things that we were trying to do with this is to leave everything in the DHCP negotiation, let it be part of that whole DORA piece, and not have to go out and bring in HTTP and other resources and go all over the place to probe. So it's trying to keep it simplified, and I could definitely, if you, I know I'm out of time here, so if you wanted to discuss it further, please reach out. Thank you.
My motivation personally is more about reinventing the wheel, and just as far as DHCP goes, making changes to DHCP clients and servers is also hard. So that might not be a good reason. Anyway, enough. I should stop.
Yeah. Thank you.
Thanks, John. Remco.
Excellent. Good. Thank you for letting me present here today. My name is Remco van Mook, presenting on IPv6 resolved IPv4 gateways that David already alluded to in his earlier presentation. This is an individual submission. What is it about? Well, let's see. So the basic premise is we're going to need to communicate over IPv4 across the internet for a good while longer. And talking to IPv4 to the internet is not necessarily the same thing as talking IPv4 locally. It's going to be a long time before a router doesn't know what an IPv4 packet is anymore, much to the dismay of some of the people in the room, maybe. And discovery mechanisms like ARP are a really bad idea in multi-tenant environments, especially if you have a modern orchestrated network that knows where to send packets anyway. And a layer 2 network knows how to carry v4 traffic. I'm just going to go through these quickly because this is all stuff you know, I guess. So what's the dream here? What am I shooting for? Have a network that focuses solely on IPv6, so no v4 subnets. A little bit like David described earlier. You have automated orchestrated addressing, prefix delegation. Your routing is based on v6, and v4 addresses are really just a tag on a host that is there for backward compatibility, so your software, your sockets can connect to it, and the rest of the internet can sort of have traffic end up there. The network knows how to move traffic, RFC 8950, as we mentioned a couple of times in this session already. The challenge, however, is that if you follow v4 via v6, the host itself doesn't necessarily know how to send v4 traffic back to the internet. So in a picture, you have this dream where you have a reflector perhaps injecting this v6 next hop route. So the traffic comes down from the internet into the host, but then the host doesn't really know where to send the internet traffic back to. So what is an IPv4 default gateway? You all know this, obviously. Your IETF attendees. In many cases, it's really the only other device that the host or a CP talks to on a public network. And the main function is really as an identifier to do a layer 2, a MAC address lookup, if you will. And the value of that identifier doesn't actually matter as long as the host knows which interface to use to send that lookup on. And so what if we combine all of that together, and let's have a v4 gateway address that actually means, if you're seeing this, you understand what this means. Use the v6 default gateway layer 2 information to send packets out to, instead of having everyone building their own hacks, because this is already something that's happening on IPv4 quite abundantly. Having a special purpose address, having a standardized address for this actually means you can build this into network stacks of operating systems natively. So the proposal draft is to use the next available address from the IPv4 special purpose address space, which is 192.0.0.11. So what does that look like? Well, the internet knows how to send traffic to the host, and the host then knows 192.0.0.11. Oh, fantastic, and then goes up again. So a little bit about offlink default gateways, because that's something, some of the comments I've had when I presented on this at RIPE 91 2 weeks ago. This really isn't defined in any current IPv4 standards or BGPs or anything. The only RFC that I could find that actually comes close to it is the historic RFC 1027, which is really more about proxy ARP, and let's not start talking about proxy ARP. But the functionality is in wide use right now. There's a whole bunch of hosting providers using this in a v4 only context. I actually tested this on like a whole bunch of operating systems and setups that I could find. Pretty much everything I threw against it worked. Potentially that's a hackathon topic, I don't know. But really, what would this do in terms of backward compatibility? You have a DHCP server that sets a 32 for the host IPv4 address. You set a host route for DHCP. Actually, what David pointed out to me, pretty much all the DHCP clients out there actually understand this already. So the host route is actually not even needed. You set 192.0.0.11 as a default gateway. And in addition, to make this work for hosts that also don't understand this, you configure .11 as an IP on a router interface, so the router will still send ARP replies. The beauty of this is that you can do incremental implementations on this. Everything works right now, and the more people implement this, the more traffic will actually move away from using the v4 lookup and actually be using v6 and v6 only. Sample of the DHCP config, you can ignore the static route in there. So what needs further clarification? So what happens in the case of multiple v6 default gateways? And one of the things that's not in the document is what kind of scope for selection do you use? I think that should be at the interface level. Do we need a cookbook, configuration examples? There was a comment from the IANA saying, hey, we've renamed the special purpose registry. So that's already in my next version. And of course, there's the v4 via v6 standards and whatever automation reference we want to push across. So with that, your thoughts, please. I would like to thank Tobias and Warren and Jen and David and others so far for their feedback. I've had this working, I have working code in the Linux user space using RTNetlink to track the gateway and then sort of reflect that in the v4 stack. But I mean, there's a million other ways you can implement this. This actually aligns really well with the v4 via v6 that was also brought up earlier today. There's a GitHub with the current draft, my email. And my question to the working group here today is, are you willing to adopt this?
Thank you very much. So we have David in the queue.
David Lamparter, very much on board with this, agree that there's a few things to figure out. That's not the point here. One thing that really raised the flag for me is you say on slide 9 to configure the IP address on the router, the 192.0.0.11. That's the one thing I really don't want to do. The router will use that address as a source address. Every router in the network will think it has that address. Just make it so it replies to ARP for that address, but don't have the router own the address. That's the only thing I really had a flag here on.
Absolutely. I mean, that's a fair comment. Absolutely. Thanks, David.
Tobias Hirsch, Max Planck Institute for Informatics. Of course, also a great fan of this work. Concerning the draft, I think there's a lot of things that need to be put in there. There's no BCP 14 language, etc. But I'll try to make a pull request for that. And apart from that, I think the whole discovery aspect needs to be fleshed out a bit more. It was clear from the slides that you do see a large role for using V6 GUAs as the targets and do the assignment that way. But I think fleshing that out a bit more also in the draft might be good.
Yeah. I mean, just to provide a little bit of context here, the draft was, I mean, I did a lightning talk on this in Romania 2 weeks ago. And as soon as I got off stage, Jen came to me saying, great, that you have 6 hours to submit this because that's the deadline. So I didn't really have time to revise the draft anymore.
All right. Could we have a show of hands? How many people have read the draft? Okay, we have a few. So yeah, I encourage you to continue the discussion on the mailing list, but we have at least some 6-7 people that have read the draft. Thank you.
All right, thank you.
Okay, so Christoph.
Hello, my name is Krzysztof Szarkowicz from HPE Juniper Networking, so HP today, previously Juniper Networks, of course. So I will present ICMP error handling in the SRv6 based VPN networks on behalf of my co-authors. So essentially, so reminder here, the RFC 9259 explains how the existing mechanism for ICMP error handling can be done in SRv6 networks. However, it doesn't address the use case when we start the ICMP, this trace route from the CE devices. So when we started the CE devices, the P1, P2 node has no context how to respond to this, how to generate the errors and to send the ICMP errors messages. So we are talking here about the use case in a uniform model. So in the uniform model, we have TTL messages or TTL and hop counts continuously decreasing across the network. So when I start my trace route from CE1, on P1 we're decreasing this hop count or TTL depending what we have. Then on P1 again we're decreasing, on P2 again we're decreasing, and so on. So which means on P1 that is doing the encapsulation, we need to copy the TTL to the hop count of IPv6 encapsulation or hop limit to the hop limit of IPv6 encapsulation. So now the example here, so we are talking here about in the context of VPNs in SRv6 network. So that example, C1 sends a trace route with hop limit or TTL set to 2. On P1, we decrease this hop limit or TTL to 1 and copy this value to the hop limit of external of IPv6 header, yes, that we push on the P1 for SRv6 networks. On P1, on provider 1 node, we drop this packet, yes, because the hop limit will be set to 0. Now the question is how we send this packet. P1 has no context of VPN, so P1 has no information about the VPN addresses at all. This is not in the transit. Further, P1, is IPv6 only, probably not. If the C1 generates the IPv4 trace route, the P1 has as well some problems here and so on. So what we're proposing here is that in the step number 3, P1 generates the ICMP error message because hop limit went to 0. If this is, if original ICMP message was IPv4 that we are proposing here to use node ID object, as was mentioned here in the previous discussions to describe what's happening here. And then we encapsulate this error message in the original stack that was received. So which means we are sending this message in the direction of PE2. Okay, we are sending this direction in the PE2. On PE2, we are de-encapsulating the message. On P2, a VPN context. This is provider edge router with the VPN context. We are doing the lookup for this ICMP error message, and as the result of the lookup, it is decided to send back in the direction of P1. So we are doing again encapsulation of IPv6 and sending this error message back. And then P1 is doing decapsulation and sending error message, ICMP error message back to C1. So this is essentially what we are proposing here. So this is more or less similar to the MPLS networks. Yes, in MPLS networks we have the same problems, and we're proposing here similar solutions in the context of SRv6. There are some discussions in which working group to adopt that. So we have presenting that in this working group. Apart from that, in the spring and in 6-man, because all this related. So at the moment, as far as I understand, it's not decided in which group eventually the work will go ongoing. But of course, we are asking for comments. We already received some comments, implement some comments. Thank you.
Thank you very much. Right on time. So any final questions, remarks for Christoph or the team? All right. So
thank you very much.
Thanks to you, and thanks everyone for attending. So see you next time.
Thank you.